Hey guys, my name is Sandeep Patel. In this video, we are going to solve one more problem based on the recursion. In this problem, we are given an array and we have to reverse that array, right? If you haven't watched my video on the recursion approach, I would suggest you watch that video first because it gives you a detailed explanation on how the recursion works and how we can solve problem using recursion. Alright, so from that video, what we learned is that whenever there's an array, we can solve the array problem using recursion two-step approach. So in the step one, we will break the problem into a subproblem, right? And then in the step two, we solve that subproblem, I mean the base case. So there are two steps, the recursion case and the base case, right? Alright, so let's take an example. So let's say that I'm calling this function by passing an array 1 2 3, right? So now in the step number one, we have to break the problem into a subproblem, right? And the way I'm gonna break this array into a subproblem is by removing the first element from the array each time I call the same function, right? So basically I'm gonna call the same function but remove the first element, right? And then second time, now I have new array where I have only two elements, so I'm gonna cut the first element. I'm gonna remove the first element again. So now it has only one element left, and finally um, when I call the next um, function, there are no more element in the array, right? So this is the base case, right? We cannot go beyond this point because there are no more element to process, right? So I call this as a base case, right? So we first started with the initial array and we broke the array until we got to the smallest problem that we can solve, right? So now you can easily solve the problem, this subproblem, right? So when array is blank, the reverse of the array is blank array itself, right? So you can say that we solve the step number two first. So that's a base case, right? Where we hit array dot length become less than equals 0. At that time we return simply blank array, right? Okay, now we also learn how to break the problem into subproblem, right? Basically we are from the initial array we have to remove the first element and call array itself, right? Call the same function again. So let's say this is step number one. Step number one, break the array into smaller problem, right? So we call the same function and we slice one element from the array, right? So basically what this code does is each time, so when we initially pass 1 2 3, it's gonna call 1 2 3, right? And then it's gonna go here, it's gonna remove 1 and then call 2 3 and then go again, right? We again hit this case, we remove 2, call 3, right? And then again we have array length greater than 1, we remove 3, now we have no more element, so it's gonna hit this base case, right? And return empty, right? So if I run this code, all you see is the empty array, right? But we haven't solved the problem of reversing the array, right? So the way we can do is like when we return, right, from the last step. So when we return, what we can do here is that we can create a new array, right? And then we spread the existing values, right? So for example, so in the last step when we return empty array, right? So when we spread the empty array and then the first element that we removed, we put it at the last, right? So let's say we remove 3 in this step and we put it on the back of the array, right? So now this becomes um, array of 3 only, right? So now this is our return value which we can use in the previous call, right? Here we are gonna spread what we got from the last step, right? And then add the element that we removed, right? In this case 3 2. So now this array becomes 3 2, right? And then we do the same thing again in the last step. When we return, we create a new array, we spread the previous two elements, and then we added 1 to it, right? So now our array becomes 3 2 1, right? And that's how we can reverse the array, right? So basically what we're doing here is that in this step we're going to create a new array and we spread what is left, and we are going to add a single element, like the first element that we remove, right, which is this step, right? So each time we remove element, so let's say we remove 1, we had 2 and 3 left, so we spread 2 and 3 first and then we added 1 at the back, right? So now if you run this code, you're gonna see that it's properly reversing the array, right? Alright, so we solved this in a really easy manner, right, using two-step approach. So now it's time to find the time and space complexity of this code, right? So for time complexity, what we are looking for is that in this function, each statement, how many times this statement runs, right? So when we run this function, this code runs only one time. So this is O of 1. However, this reverse function calling itself n times until we have 0 element from the array, right? So if array has a length of n, then we are calling this function n times, right? So we can say that this function has O of n space complexity because it's calling itself O of n time, and O of n is the bigger complexity in this function, so we take that as our time complexity. Alright, how about the space complexity? So for the space complexity, we are not using any variables here. However, in this return we are creating a new copy, right? So this copy would be the same array length, right? And basically we're reversing the same array, so it is using O of n times, right? It also uses the recursion stack, right? So whenever you use recursion, it occupies the stack memory, right? Basically if recursion is calling itself n time, that means in the stack memory there are n calls pending, right? So those O n time space, those n time stack functions takes O of n memory as well, right? So there are two. So this call here takes O of n, and this copying the array element takes O of n. So we take the bigger value from both, right? So O of n in both cases is O of n, so we simply take O of n as a space complexity. I hope you like this video. Please do like, comment and subscribe. Thank you very much.